Hello. In this video, we're going to take a look at finding the zeros of a polynomial function using the rational zero theorem. So the rational zero theorem gives us a way to make some educated guesses on our zeros of our polynomial. And then we can use synthetic division to find and help us factor our polynomial. So our first example, we've got f of x equals 2x cubed minus 4x squared minus 14x plus 28. For the rational zero theorem, we are going to look at factors of that constant 28. And so for 28, our factors are going to be plus or minus 2, 4, 7, 14, and 28. Oh, and I missed one on the front end of my list. So 1, 2, 4, 7, 14, and 28 are all the numbers that go evenly into 28. And then we're going to do the same thing for our leading coefficient of 2. And so the numbers that go evenly into 2 are plus or minus 1 and plus or minus 2. And so our possible rational zeros are going to be any combination of something from that first list divided by something from the second list. So we'll get 1 over 1, 1 over 2, 2 over 1's already on our, 2 over 1, 2 over 2's already on our list, 4 over 1, 4 over 2's already on our list, 7 over 1, 7 over 2, 14 over 1, 14 over 2 is already on our list, 28 over 1, and then 28 over 2 is already on our list. And so we're going to pick one of these and try to see if it will go in evenly. We can use our calculator to help us out. We go to our y equals menu and enter our function into our y equals menu, and then go to our table. Let's do our table set first. So second window to get our table set. And if you want to, you can change your independent to ask and then just plug these numbers in. So change independent to ask, highlight ask and hit enter. And then go to the table and plug in this number. So we try 1, we get a 12. That's the number in the right hand side is what we get if we plug in. In order for it to be a 0, of course, it has to equal 0. So we want a 0 over there. Negative 1 doesn't give us a 0. What about 1/2? Or negative 1/2? None of those give us zeros. What about 2? 2 gives us a 0. So what we want to do is we want to divide by the factor that'll give us a 2. So if x equal 2 is one of our solutions, that means if we kind of work backwards, x minus 2 equals 0 is going to be one of our factors. Just like when you're factoring, using factoring to solve a polynomial, going backwards, we're doing the same step. So that means x minus 2 has to be a factor. So let's use synthetic division to divide this polynomial by x minus 2. Remember, we always change the sign. So instead of x minus 2, we're going to get a 2 there. And then we're not missing any terms here. We've got an x cubed, x squared, x to the first, and a constant. So our coefficients are going to be 2, negative 4, negative 14, and 28. The 2 comes straight down. 2 times 2 is 4. Negative 4 plus 4 is 0. 2 times 0 is 0. Negative 14 plus 0 is negative 14. And 2 times negative 14 is negative 28. which does in fact give us 0 for our remainder, so it goes in evenly. So what we have done is we have one of our factors here in x minus 2, and our other factor is represented by the coefficients that are going to be left as part of our quotient. So we have partially factored our function to x minus 2 times, remember this is going to be the number closest to our remainder is going to be our constant, and then we get an x and an x squared. So this is going to be 2x squared plus 0x minus 14. If we're trying to find the zeros here, we just need to finish factoring this. This is a quadratic, and so we are done with synthetic division. If we can't factor this, we can use the quadratic formula or completing the square to finish solving it. X minus 2 we can't factor anymore, but so x minus 2 equals 0 gives us x equals 2. And then we can finish factoring this one, factor out a GCF of 2. So we'll get 2 times x squared minus 7. And that's not a difference of squares, but we can think of that square, that 7 there, as the square root of 7 squared. And so we can think of it as 1, so we can actually factor that to x minus the square root of 7 and x plus the square root of 7 if we wanted to. And we'll get our 3 answers. We'll get x equal 2 out front, and then we'll also have x equal 7 and x equal negative 7 from our other 2 factors. And so those would be our zeros. If you're looking for the factors, your factors in the completely factored form is going to be x minus 2, 2, x minus the square root of 7, and x plus the square root of 7. All right, let's do another one of those. Same problem, just a different wording. Solve the equation in the real number system. So here we're solving our equation. We're doing the exact same thing we just did. Our polynomial is x to the 4th minus x to the 3rd plus 2x squared minus 4x minus 8 equals 0. And so we're going to start out the same way. Factors of our constant, negative 8. That's plus or minus 1, 2, 4, and 8. And then our leading coefficient, the coefficient on our x to the 4th is an understood 1. And so we only get plus or minus 1. So our possible rational zeros, the list that we're going to choose from, we get plus or minus 1 over 1, 2 over 1, 4 over 1, and 8 over 1. So we're only getting those 4 positive and 4 negative ones. And then we can pick one of these. We can do the same approach we did on the last one, or we can just kind of plug and make a guess. Let's try 1. If we try 1, if we plug in 1, we get 1 to the 4th minus 1 cubed minus 2 times 1 squared minus 4 times 1 minus 8. Again, you can use your calculator to help with this. We're going to get 1 minus 1 is 0. Minus 2 is negative 2. Minus 4 is negative 6. Minus 8 is negative 14. So that one doesn't work. If we try a negative 1, we get negative 1 to the 4th is a positive 1. Negative 1 cubed is going to be a negative 1, but we're subtracting it. So this is going to be 1 plus 1. Negative 1 squared times a negative 2 is negative 2. Negative 1 times negative 4 is going to be a positive 4 minus 8. Oh, I have a sign wrong. It's like this one was supposed to work. That one should be a plus, and that one should be a plus, and that one should be a plus. So we get 4, 5, 6, 7, 8 minus 8 is equal to 0. So that one works. So let's do our synthetic division and figure out what our quotient is. So we're going to we're looking at x equal -1, which means x plus 1 is going to be a factor. So we change the sign. Always change the sign from the factored form. And then our coefficients are going to be 1, -1, 2, -4, and -8. Our 1 comes straight down. -1 times -1 is -1. -1 plus -1 is -2. That's going to give us a +2, +4, -4, -8, +8, and 0. So that just double checks and gives us assurance that we did it correct when we plugged in our -1. So we have factored this to x plus 1 times, remember this number closest to the remainder is our constant, and then we're just going to increase powers of x's as we go across. So we'll get x cubed minus 2x squared, positive 4x minus 8. So we've got it partially factored. We just need to finish factoring it. If you realize that the cubic polynomial here is something that will factor by grouping, then you can factor that out. If not, you can just repeat that same process with our polynomial with our quotient here as our starting point. And so we still have factors of 8 over factors of 1, so we're going to get the same list of possible rational zeros that we got on the previous one. And so this time let's try x equals 2. So if we try x equals 2, we are checking the factor x minus 2. And so we're going to get 2. And then our coefficients, we're looking just at this part right here for the time being. 1, -2, 4, -8. That 1 comes straight down. 2 times 1 is 2. -2 and 2 is 0. 0 times 2 is 0. Plus 4 is 4. 2 times 4 is 8. -8 is 0. So we have our x plus 1 from our previous factoring. And then we have our x minus 2 from the second round. And then what we're left with, that 0 is our remainder. And then we get 4 0x's and 1x squared. So that's going to be x squared plus 4. X squared plus 4 does not factor any further. And so this would be the factored form. So that would be as far as we could factor it. And we can set each of these equal to 0. X plus 1 will be equal to 0 when x is -1. X minus 2 is going to equal to 0 when x equals 2. And then x squared plus 4 is going to equal to 0. Subtract 4 from both sides, and then take the square root. We get x equals plus or minus 2i. So those will be the 4 solutions to our equation. But remember, the directions said solve in the real number system. So that 2i is an imaginary number, so we're only interested in the 2 and -2 in the real number system. All right, I'll see you guys next time.